Welcome to your comprehensive interactive study breakdown on static electricity, a core topic for AQA GCSE Physics specification point for point 2.5. Today we'll explore how charge builds up on insulators through friction, the invisible electric fields that cause attraction and repulsion, and for higher tier, how strong fields can rip electrons from air molecules to create sparks. Mastering the precise vocabulary, like electron transfer and a non-contact force, is essential for securing full marks in exam questions. Let's break it down scene by scene. Let's map out the core ideas. At the center is charging by friction. When you rub two different insulators together, electrons transfer. One gains electrons E negative, the other loses them, positive. Around that, every charged object creates an electric field, which exerts a non-contact force on other charges. Opposite charges attract, like charges repel. For higher tier, a strong enough field can pull electrons out of air molecules, ionizing the air and allowing a spark to jump. These concepts are interlinked. Turning to our core study notes, when charging by friction, remember the golden rule: only electrons move. Protons stay locked in the nucleus. Electrons transfer from the material that holds them less tightly to the one that holds them more tightly. The material losing electrons becomes positively charged, the material gaining electrons becomes negatively charged. Since insulators don't allow charge to flow, the charge stays on the surface. And total charge never changes, it's just redistributed. A classic example is a polythene rod rubbed with a duster. The rod gains electrons and becomes negative, the duster loses and becomes positive. Now let's walk through the process of sparking, which is higher tier content. When a large amount of static charge builds up on an object, it creates a very strong electric field in the surrounding air. This field is so strong that it can tear electrons away from air molecules. This is called ionization. The freed electrons and positive ions then accelerate in the field, colliding with other molecules and creating more ions in a chain reaction. The air becomes conductive, and a sudden discharge of charge, a spark, jumps to a nearby object. This is exactly what happens in lightning, just on a much larger scale. Let's work through a 6-mark exam question, explain why a polythene rod becomes negatively charged when rubbed with a duster, and describe the electric field around the charged rod. To score full marks, start by stating that rubbing causes friction, which provides energy for electron transfer. Electrons move from the duster to the rod because the rod holds electrons more tightly. The rod becomes negative, the duster positive. Then describe the electric field. It is a region where a charge experiences a force. Field lines radiate inward toward the negative rod because field lines go from positive to negative. Mention that the force is non-contact and the field is strongest near the rod. This structured answer hits all the key terms the examiner expects. Watch out for common pitfalls that cost marks. First, never say protons or positive charges move. That's an instant error. Second, remember that static charge only builds up on insulators, not conductors, because charge can flow through conductors. Third, when describing attraction or repulsion, always use the phrase a non-contact force. Examiners love to see that. Finally, for higher tier sparking questions, you must mention ionization of air molecules, not just a strong electric field. Be precise: the field ionizes the air, making it conductive, then a spark jumps. To wrap up, remember the essentials: static electricity is all about stationary charge on insulators. Only electrons move, protons are fixed. Charged objects create electric fields that exert non-contact forces, opposites attract, likes repel. On diagrams, field lines always go from positive to negative. For higher tier, a strong enough electric field can ionize air, leading to sparks. Keep these key terms in mind: electron transfer, insulator, non-contact force, and ionization. Use them in your answers to demonstrate exam-level understanding. Good luck with your revision.